In BGP, this next hop behavior is very important topic to understand. BGP is an autonomous system by autonomous system routing protocol. So when we learn routes, the routes will always point towards the next autonomous system address. The address that we use to identify next autonomous system is what going to be the next hop. The reason is BGP is an autonomous system, not router by router. It is autonomous system by autonomous system routing protocol. If it is router by router routing protocol like OSPF, then the next stop will be the immediate router. BGP is autonomous system by autonomous system. That's why I showed you in the example in the previous class. Router 2 was not showing next stop as router 4 or router 3. It was showing the router which is out of this autonomous system, which is in the next autonomous system. So in BGP, the next autonomous system does not mean the next router, it means the IP address that we form neighborship with the next autonomous system router. It need not to be the directly connected physical interface address, because sometimes we do eBGP multi-hop. So I want to add here saying the next hop address will be the address of the neighbor, the address through which you form neighbor, not the address that is directly connected. See, by default, eBGP neighbors need to be directly connected. In that sense, this statement is written. The next hop does not mean the next router, it means the IP address to reach the next autonomous system. See, sometimes the IP address to reach next autonomous system may be this address, but the neighborship that we make may be between loopbacks. In that case, it should not be this statement, it should be the IP address with which you form neighbor. If this is 2.2.2.2, let me make it as 1.1.1. Now this is router 1, router 2. So when I learn a network, for example, 20.000/30 or whatever, 24, when I learn here on R1, this route is given to eBGP, and eBGP gives to iBGP like this. 20.0.0.0 is in the next hop 2.2.2.2, not this IP address. The IP address here may be 42.0.0.2. This may be a reachable address to reach the next autonomous system, but we did not use this address to form neighbor. We are using 2.2.2.2 as a neighbor address on R4. So this is what going to be the next hop. So in that way, this statement is wrong. So what is the right statement? The next hop means that the IP address with which you form neighbor with the next autonomous system. Now let's move on to the third paragraph. For eBGP, the default next hop is the IP address of the neighbor router that sends the update. So how do we send the update? We are sourcing with loopback 0 if we are using eBGP multi-hop. I'm just trying to continue from the yesterday's scenario. If I don't use yesterday's scenario, then we will have a neighborship using this 42002, that will be the default exit interface from where the updates will be sent. If we are continuing our previous class, then I should say the updates are sent from the update source 2222. That is going to be the default next hop IP address. Now for IBGP also it's the same address. Why? For IBGP, the BGP protocol states that the next hop advertised by eBGP should be carried into IBGP. So router 4 should not change the next hop before advertising to R1. It should carry the same next hop that is received from eBGP. But if in case you are not able to reach, if R1 cannot reach the next hop, R1 will not consider it as the best route. The learned route will not be considered as the best. If it is not considered as the best, that route won't be used by the router to forward the packet. So to make it as a reachable next hop, we used to use next hop self on the fourth router. So that router 4 will put its own address 4.4.4.4, which is reachable via the route given by OSPF from R1. Now let's see this example here. Router A is advertising 172.16.0.0 to router B. And the next hop is going to be the default exit interface 10.10.10.3. And router 3, when it advertises that same 172.16.0.0 into IBGP, which is RC, router C, router B will not change the next hop with its own address. Rather, it will keep that same 10.10.10.3 as a next hop while advertising to C. So C receives with the next hop 10.10.10.3, though the packet is coming from router B 172.20.10.1. This is default behavior. So to override that behavior, we need to say next hop self. This will force all the updates for its IBGP neighbor to be advertised with this router's address as the next hop. The IP address used for the next hop self option will be the same source IP address of the BGP packet. So if you are sourcing with the loopback, then loopback address will be the next hop. If you are sourcing with the default exit interface address, then that will become the next hop. And here is an example. Kindly go through this picture for a minute and let me know if you have a question. Right, so correct. RC, when it advertised to RD, it will put its own address for which you no need to say next hop self. Because it is autonomous system by autonomous system protocol, when a router gives a route to another autonomous system, it must put its own address, should not carry whatever comes in. See, what is coming here is 2222 as a next hop. It won't carry to eBGP. This 2222 will be carried to IBGP if you have another router here. 2222 will be carried as a next hop to this router, but to eBGP it will put its own address. For this, you no need to say next hop self. No problem. I'm going to make it clear. Listen, I'm going to do it from the beginning, this topic. You see, let us say I have a router called E. What is the relationship between C and E? IBGP. IBGP. Fine. Now this network called 10.0.0.0 is connected to router A. Router A, when it advertises it to B, the exit interface address of router A becomes the next hop address when it is received on B, because that is the source from where the packet is coming. You're right, source address of A that becomes the next stop for B. Now, when B forwards it to C, usually it will not put its own address, it will simply carry whatever comes in from EBGP. So it used to advertise 172.16.11 as the next hop when it advertises to C. But because we have said next hop self on RB, because we told RB not to keep the same address but to change its own address. We say to RB, whenever you speak to this guy, router C 333, put your own address as the next hop. Put your own self address as the next hop when you send the update that you received from EBGP. So it received 10.10.10.10 from EBGP. Now it puts its own address and send it to router C. Now when router C forwards it to E, it will forward exactly the same thing, because C and E are IBGP. C will forward it to same with same next hop, but again, there is an IBGP split horizon rule. You should have said route reflector. Usually the routes coming from IBGP will not be given to another IBGP. So to make it forward, we need to either make full mesh or reflect the route. So when you do reflection or a full mesh, E will be receiving 2222 as the next hop, not 33333. But when D receives, D and C are EBGP neighbors. When D receives it, it will receive with the next hop with which D is forming neighbor with C. D is forming neighbor with C using 192.168.1.2. It is 192.168.1.2 is the one which is the source of this packet now, going from this autonomous system to that autonomous system where D is. So in short, what I want to say is, when D receives, the next hop will not be A address, and next hop will not be B address. It will be C address. For this, there is no need of any configuration. This is the default behavior. This one or before this? This one. Hmm. This is for D. For between C and E. B, C, and E. It is IBGP, no? For IBGP only that rule. For IBGP only that rule. Hmm. Yeah. Yes, correct. BGP speaker, BGP source, all the same. Yes. Yeah, please. Now, this is something important here. This is also a next stop behavior, but in a multi-access network environment. What do we see here? There is a network from router C. There is a network advertised by C. And the network is 172.30.0.0. Who is the owner of the network? Router C. And that network is advertised by B to A. Why? There is no neighborship between B and A. Sorry, C and A. There is no peering between C and A. The neighborship is between A and B and C. So whatever C advertises, B takes it and B advertises it to A. When A receives, it will receive with next hop 10, 10, 10, 2, not 10, 10, 10, 1. You see the difference? No. See, the reason is the eBGP is between A and B. But who is the source of this in that autonomous system where B is? C. So when the source belongs to that same autonomous system, and you see the subnet is same 10, 10, 10, 10, 1, 10, 10, 10, 10, 2, 10, 10, 10, 10, 3, which means they have one common layer 2 domain. This is what called as multi-access network. In a multi-access network, the original source, even if it is not a neighbor, but still the original source will be the next hop. Why? If it is this one as the next stop, then packet has to go like this and take a U-turn and go like this. It's not good. So to avoid such unnecessary hops, BGP is designed. BGP is efficient enough. BGP is clever. See, to avoid unnecessary hops, BGP is being efficient by informing A of the best entry point. The best entry point is like this. The router B in AS65000 also advertises to 6450 that the best entry point for each network to 64600. So not only for this network, even for the network coming from D, the best entry point is going to be like this. So packet need not to take a long route. This is a very nice feature, very nice smart behavior. So when BGP advertises network in a layer 2 domain in a multi-access environment, instead of using the neighbor address as the next hop, it will give the best entry point address. Because the neighbor address and the entry point address are in same subnet. This is the smart decision BGP does. Question? Any question? See, actually, they are showing what is default. Who is advertising this 172.30.0.0 to router A? No. Who is advertising to A? Who is giving to B? B is giving it. But originally it is coming from C. B and C are in same subnet with respect to A. They are in same subnet. So this is by default it is possible. You don't need to do any extra work. I have tested this. This is how it will work. I have tested this. Yep. So but you understood, no? Because there's nothing more to explain here. When B advertises to A, B will say, "I am not your best entry point because there is an advertiser who is in the same subnet." You can simply switch to C, layer 2 communication. Instead of you coming through me, and you simply go straight to C. Of course, this is a switch. Yes, it is a switch. This is the picture of a switch. Every layer 2 will be drawn like this. Layer 2, this will be drawn. But they are connected to same subnet. That's what called multi-access. All right. The final topic in this chapter is peer group. Yeah, because if it forwards the packet to B, B will use the same layer 2 domain to forward it to C. It is unnecessary switching. Now C and A is not a neighbor. That's why C cannot give directly to A. See, that is default. That is how we think. That is how we think. Based on what we learned in the past, we would think that packet should go to B because B is the source of packet, source of update. But what B will do is, if the original source and B's own exit interface address are same subnet, then B will simply carry C's address to A. That's what the new learning that we have here. See the second paragraph. B is being efficient by informing router A of the best entry point into AS65000 for network 172.30.0.0. So this is, again, I'm telling you, this is a default behavior. Whenever you see layer 2 switch connected, this is how we should understand, not the other way. Okay, exactly. Exactly. But most people will say the next stop will what? 10.10.10.1, which is wrong. Those who have not learned in depth will think that it will go to B because B and A is what neighbor. B and A is what neighbor. C and A is not neighbor. So mostly people will think that it will go to A, B, and B will forward it to C. But that's not the way it works. See, it's like, three routers in same VLAN. And this is EBGP, router A. And this is B, and this is C. C is advertising a network to B. B is advertising that same network to A, but it will put the address of C and advertise so that A can go directly like this. Not like this. That's useless. All right. So shall we go to the next topic? Yeah, it is. Yeah, please do that. You'll enjoy it when you do that. It'll be like, wow, yeah, exactly what is said in the document is correct. I've done this in my classes. See, I'll also do this in your class when we do the demo. Peer group is like IBGP group or peer groups. Peer group is like a template that you want to create and use it again and again. Like a global policy. Yeah. If I need to say in the language of software defined solution, peer group is like a global policy, which you can use it again and again with various other units. For example, here, if you see the next page, peer group is like creating a global policy like this. The policy name is internal, and you say the next stop, sorry, the route, the remote area should be this. The update source should be loopback 0. Next stop self, and it should use the distribution list 20. Forget about this if you don't understand now. We don't need this. So we have something common for many neighbors. So we create a policy with these three things, and we call the policy so that you no need to apply the policy with every single neighbor the same thing again and again. See, these 4 lines are repeated again and again with 3 neighbors. So there are 4 code of line. But if you see here, it is only 3 lines, 3 neighbors. That's the same job for all 3 neighbors. We said remote AS65100, update source loopback 0, next up self distribution layer 20. You see, the line of code is less. Not only that, the process is going to be utilized less. Meaning, in one process, in single go, you have applied all this to the neighbor. Whereas here, you press enter, this gets processed. Press enter, this gets processed. This many times you repeatedly go and disturb the processor. Here it is just single go, one neighbor configured, one process. So what's the advantage of peer group? Peer group helps to configure the common configurations, common policies in an easy way. Instead of repeating the same configurations with multiple neighbor, we create a template. We put those common configurations in the template. We call the template to whichever the neighbor we want. Let's go back and read now. This command defines the template with a parameter set for group of neighbor instead of individual. See, mostly it is done between IBGP neighbor. This command is useful when many neighbors have the same outbound policy. The members can have different inbound policies. That doesn't matter. Say outbound is what it says. Means when I send the packet out, it should be sourced from loopback 0. When I send the packet out, the next stop should be my own. When I send the packet out, it should be sent according to what the distribution list says. If the distribution list says permit, it should be permitted. If it says deny, don't send it. You know, so it's all outbound policy. Inbound policy can be anything for those neighbors. Updates are generated once per peer group. That's what I said. Without peer group, updates are generated again and again as you hit enter. When you configure this, outgoing packets will have source address as the egress interface. When you configure this, outgoing packets will have loopback interface. So it keeps changing. Whereas with a peer group, it is once per member. So the configuration is simplified. Less number of codes. Any question on peer group? Please ask. All right. So if you want to advertise, it's not a part of peer group. Yes, exactly. Exactly. Uh, See, when you advertise the update, it's outbound. When you receive the update from outside, it's inbound. So this is not impacting the updates coming from outside to in. It's impacting only the packet goes from this router to outside. When you send outside, I'll say I belong to this autonomous system. When you send any packet, you need to say I'm coming from this source address. When you send outside, you need to put your own address. It's all sending out. That is with respect to the firewall you need to write. We'll have a separate class on access list. Yep. See, every other protocol except BGP, every other protocol, we use only network command. That network command will run that protocol on the interface where the network is. Not only running the protocol, it will also advertise those networks. Whereas in BGP, forming neighborship is different from advertising network. Whereas in the other IGP protocols, forming neighborship and advertising the network both works together. One command network. So far we have not seen how to advertise. Here to advertise we use the command network. The neighbor command and the neighbor's subnets are not going to be advertised unless you advertise using network command. Network command only advertises a network. The neighbor subnet or neighbor address is not going to be advertised in any point unless we use the command network. No networks get advertised. And when you're going to advertise a classful network, you no need to use the mask command. But if you have a classless address on the interface, usually we have only classless, then you must use the mask command to match the mask on the interface. We must match the mask on the interface if you want the advertisement to be done. So this command tells the BGP what network to be advertised. The command does not active the protocol in the interface. For that you need what? Neighbor command. Without a mask option, the command advertises only classful network. If a subnet of classful network exists, meaning if it is classless, you need to use the mask command. If not, if you have only a classful network, only the classful network get advertised. Right, so here it is. Here is the example. If you have a route in the routing table with 192.168.1.0, this is a mistake actually. You cannot put 1 here and 0 here. It won't accept. It will throw error. If you have a route in the routing table 192.168.1.0 and you don't need to really say mask because it's a default mask. If it is seen in the routing table, it will advertise. If it is not seen, it won't get advertised. So as soon as you put some network command, it will try to match with the routing table. So if you will have a summarized route in the routing table with /16, assume you have a summarized route in the routing table with /16. Only then this is going to be active. This will advertise this 192.168.0.0. Or let us say you want to advertise a summary route like this. You do not want to advertise 192.168.1.0, 2.0, 3.0. You do not want to advertise all the subnets. Instead, you want to summarize and send like this. Then what you can do is you can write a static route pointing towards null 0 with /16 and go to BGP and say, I have a route in the routing table matching /16 for this class C. For class C, the default is /24, but you wrote a route with /16 pointing towards null 0 in the routing table, which can be used by BGP to advertise. It will advertise now summary route. It's a nice lab that you can do and see. I'll also do this in our next class. So what we have seen today is we have seen how to send a summary route. This is how we send a summarized route. And we saw peer group. And we saw the next stop behavior in multi-access environment as well as in a normal point-to-point environment. The next chapter will be attribute, we have one more topic to go, synchronization rule, and then small things, and then we will, these are all small topics, but let's finish this and then we'll close the session. So we have seen how to advertise. Next is about synchronization rule. Synchronization rule is a necessary rule. What happened? Once one man was praying. Before praying, he locked the cat inside a small room. So a servant was seeing this. Whenever the saint prays, whenever this man prays, go to prayer, he used to catch the cat, put it inside the room, and lock the room. Every day he used to do this. Before praying, he will catch the cat, put it inside the room, and then he will go to prayer. After that, he will unlock the room, set the cat free. The servant who was watching this, he also bought a cat because he wanted to pray, so that he can lock the cat inside and pray. What I'm coming to say is, the reason why that man was putting the cat inside the room before prayer was the cat was disturbing him daily while he was praying. But this poor servant don't know why he is doing this. He thought that for prayer we need a cat first. Likewise, the synchronization rule, we used to turn off the synchronization rule every time when we configured BGP. It was like one cat unnecessarily purchased and locked every time you pray. Turning off the synchronization rule every time when you configure BGP is really an unnecessary. Then why we have that synchronization rule in first place? On every time if you are going to off it, then why you need it? On, correct. That is what they did. They have offed it permanently because it was like on cat. Every time you buy a cat and lock it, which has got no connection to the prayer. Synchronization rule has got no connection to any useful route distribution, but it was there unnecessarily disturbing, and to avoid the disturbance we used to off it every time. Now what is that cat here in synchronization rule means? Do not use a route, neither advertise the route to an EBGP neighbor if IBGP matches the route. See, we are not supposed to advertise nor use it if we are learning a route from, if you're advertising a route that you have learned from an IBGP until the same route has been matched by OSPF or EIGRP or any IGP route advertisement. Let me put it again in a simple way. If you want to advertise an IBGP learned route, you need to make sure the route that you are planning to advertise also available in OSPF database. If not, don't advertise to EBGP. Repeating again. Before you advertise any routes to EBGP neighbor, make sure that same route is also available in your OSPF database. If not, don't do it. What is the use of this rule? It's nonsense. Yeah, it was. No. That is different. No. Let me clarify your confusion. Listen. A route learned from one IBGP should not be given to another IBGP. Is different from the route learned from an IBGP should not be given to an EBGP. See, this is different rule. This is different. What is the currently right now in current versions? Route learned from an IBGP is advertised to EBGP. It will not be advertised to IBGP. It will be advertised to EBGP. There is nothing wrong in doing it. But earlier, because of the synchronization rule, it was not allowed to advertise until the same advertising route is advertised by OSPF or EIGRP. See, this was unnecessary rule. All those who are inside the car also should wear the mask because there is a coronavirus outside. Equivalent to that rule. You start from your house and go to your another house. Your car is closed and you are safe inside. You left the room, you left the house with your own family who are not affected, and you are going to another house, your own house. You will open the window again only after reaching the second house. inside your compound. Why this rule in the middle? Stop the car, open the window. You don't have a mask, pay the fine. Doesn't look nonsense? Of course, it is no sense in it. That is Indian government rule. Synchronization rule is also Indian government rule. How to make money in this situation? Exactly same is what synchronization rule sounded. So now it is turned off luckily. So you don't need to worry about this rule anymore because it is off. Earlier it was on. See, earlier it was like this. Synchronization rule is on earlier. So how the behavior is, see, this network is advertised to be. Now, this network is learned on D as well as C and on A because they all have full mesh IBGP. Now, A will not give it to E because the synchronization rule is on. When it is off, no problem. E will receive the root updates. No problem. So this was unnecessary. Someone wants to show that he's too much caring for the people, where there is no real burden of people. Just show off, like that corona rule. So it is turned off now, and it is good. It's turned off. Again, the synchronization rule is not at all a topic to be discussed because it's useless, waste of time. Once in a while, sorry, not once in a while, once in a lifetime, we should know that this existed in 2018, sorry, 2021 and 2020 in India. This rule was there. Inside the car, even if you're inside the car, your own private car, you must wear your mask. And you should open your window and get the virus inside and pay the fine. Fine, this is an example how to do configuration BGP. When you say router BGP 65, the router become part of the autonomous system, and you have to enable. You need to configure neighbor by using neighbor command to activate the neighbor on either side. This is an eBGP neighbor because the autonomous system number is different. This is an iBGP neighbor because it's the same autonomous system number. And we need to advertise the network if you wish to advertise, because the neighbor command is not going to activate the neighbor advertisement. We need to match with the mask if it is not classful. And this command is no more needed because it is already no synchronization by default. Now there are different states of BGP. See, different packets, different message types is different from different BGP states. Earlier in the beginning, in the first chapter, we saw different message types. Open message, notification, and then update message. That is message type. Hello, say not hello, keep alive message. That is message types. This is BGP states. When establishing a BGP session, BGP goes through the following state. Idle state, I showed you yesterday. When there is no root in the routing table, it will be searching for the root. That is the place, that is the time it will show you idle. And you will see active state if the route is found and when it is trying to form neighbor. Active state. Where active state is like, for some reason, it is not establishing the three-way handshake. The router is not able to do complete three-way handshake. In that period, it will be active state, idle to active. means trying to form three-way handshake, trying to establish connectivity, but not able to do. Yep. So, for example, if one side is configured properly, the other side may be misconfigured or not at all configured, then it will be in active state. The neighbor state will be in active state. Only when both the sides properly configured, it will go to connect state. And once the connect state means three-way handshake is completed, it will send the very first open message packet with the router ID. And now, when the receiver receives the open message and finds the source address matching with the neighbor statement, and when the autonomous system matches the incoming autonomous system and the autonomous system number configured in the neighbor statement matches, it confirms. If it doesn't match, again it will go to active state and start from the connect state again, try to connect again. If everything goes good, then it goes to the established state by sharing the route updates. So that's what you see here, idle state, when there is no route in the routing table. When you type show IP BGP summary, in the state and prefix received column, if you see a number, at least a 0, which means neighbor is established. If you see active or idle, not good, you need to troubleshoot. Or you can also type this command show IP BGP neighbor and you will see the state. So when it is active, what are the troubleshooting that we have to do? A router has sent an open packet and it is waiting for the three-way handshake to complete. It's waiting for the response. For some reason, the response is not coming. When you will not get response? When the neighbor is not ready to form BGP with you, meaning neighbor may not be configured or may be misconfigured. So the neighbor does not have maybe this is also another reason. There is no route to talk back to you. There is no reverse path. Or the neighbor address is wrongly configured, or the autonomous system number is misconfigured, or no configuration matching with the incoming source address. So whenever you have autonomous system number mismatch, then you will find this type of Fs, many Fs, as the logs appearing. And when you see this type of logs appearing in the console, you need to be informed that it's a wrong AS problem. Fix the AS number correctly, then you will not get this error. So this is what I was talking about. If you see some number at least 0, it means neighbor is established. So you don't need to type the command show IP BGP neighbor, because that command will always show you pages of information. Better to use this command show IP BGP summary instead of this neighbor command. For each neighbor, it is going to show you pages of information, which is very difficult for you to confirm the peering. This is the best one, show IP BGP summary. Now, authentication in BGP is very straightforward. No need of keychain or anything like that. Simply go under router BGP and say neighbor IP address, or group of neighbor, peer group, password, and then the password that you want to use. You type the password in a plain text, it will automatically send in an MD form, an MD5 format, encrypted authentication, hashed values. So you don't need to enable MD5, it is going to be automatic. So router generates and checks the MD5 digest of each segment sent on the TCP connection. Router authenticates the source of each routing updates packet that it receives. This is an example. Again, I'm telling you, you no need to type this ciphertext. It will automatically send only the ciphertext. But here they are trying to say that, trying to give some complicated password. Now, show IP BGP is a command which will show you the networks that we have learned from various next stops, various autonomous systems. If you see the next stop with 00, which means they are locally advertised, all the rest are coming from either eBGP or IBGP. If it is coming from IBGP, then you will see 100. If it is coming from eBGP, then you won't find any number. See, the local autonomous system number is not mentioned here. No autonomous system number is mentioned, which means it's local. This is all coming from different autonomous systems. This is the place from where it is originated. That's it. Now, there is something called routing information base failure, RIB, routing information base failure. See, BGP is not failed. BGP has given a recommendation to the RIB with regards to a destination. BGP says, hey, for this destination, this is what the attribute. If you want, you can use it. And RIB says, thanks for your information, so kind of you, but same network is given to me by OSPF. I prefer OSPF because OSPF administrative distance is 110, whereas IBGP's administrative distance is 200. So it is the RIB who told that I'm not going to use your preference because I have better preference, I have another protocol providing me the route information for the same network which you are giving me. So there is no problem with BGP here. RIB failure is not a failure of BGP. RIB failure is routing information base failed to use BGP because according to RIB there is something better than what BGP is giving. So you don't need to do any troubleshooting for this. If you wish to see what all routes given by BGP is ignored by RIB, you can type this command, show IP BGP RIB failure. Even without typing this command, you will be able to see if you notice here you have R, which means these routes are given by BGP. According to BGP, these routes are valid and best, but according to routing information based algorithm, it is not, because for RIB there is something better. All right, so now every protocol has got an option to restart in the middle while running, but it is going to be a disruptive one. If you clear IP OSPF process, the OSPF will restart and it will be a disruptive one for those who have already learned the route from the this router. Whereas in BGP you have both hard reset and soft reset. Hard reset, as the word says, it's going to be a disruptive reset. Soft reset is like a route refresh. Soft reset is route refresh, meaning you once again send and receive without removing the old info. All right, so you want to reset for all neighbor, then you put star. It is going to be a hard reset. You can also say a particular neighbor, and only with that neighbor hard reset will happen. You can also use the soft reset, where the routes learned from the neighbors are not going to be lost, will not be cleared. This router will simply resend the information once again without resetting the connection. The connection will remain established, uninterrupted. This option is highly recommended because there is no disturbance cost to the routes. Soft out option does not help if you change inbound policy. Yeah, if you are changing the inbound policy, meaning routes coming from outside to in, has nothing to do with this reset, soft reset, because it is coming from out to in. Whenever you do some changes from in to out, you do the soft reset because it is in your control. Earlier you were sending information like A as in apple. Now you say, no, I don't like apple. Let me use A as in avocado. Now, when you do the reset, it will be avocado advertised, not the apple. But in what way it is going to impact the out to in? Out to in, you need to go to that router and do some changes, not in this router. So soft reset is not going to impact the inbound route updates. It is going to only impact what I'm going to send out. This stores all the updates, the route reconfiguration inbound command. Again, I showed you this command in the previous class. That is for knowing what has been learned, but it's going to make additional buffer usage, so memory intensive. We don't use this. Clear IPBGP soft in will be useful if you enabled this, so that you can store and do changes for the inbound. But we don't do these things in production because of the conception of additional storage. Right, whenever you clear like this, you can also see what all changes that happens by debugging. See, debug IPBGP updates, and you do hard reset. When you do hard reset with our particular neighbor, see what happens. BGP sends an update fresh from the beginning. The neighbor goes down and comes up again, and you send everything again with all the attributes. You see, next top attribute and all this, the metrics. You advertise it one more time. Likewise, you receive everything fresh from your neighbor. All right, at least once, once in life, you need to do this debug and see, to know what happens when you do hard reset and what you do when you do soft reset. In our lab, we'll do these things. Right. So in this chapter, we learned a lot, like a reset, peer group, RIP failure, authentication, different states in BGP, and next up, behavior, network command. All these things we have to work out and see. We need to do a lab on all this. You have a break of 2 days. You can also try. I will also be doing this. When you try, you will have some more questions to ask on the next class.